Hi, so I'm gonna, in this video, just explain really quickly how these opetopic diagrams are arranged and how they work, and yeah, it'll just be an introduction so that you can get started working with Orchard. So yeah, the first thing here is that this whole picture here is an opetope of dimension 4. It consists of 5 connected components, as you can see, and they're organized by dimension, and they move from left to right. So over here is dimension 0, dimension 1, dimension 2, dimension 3, and finally dimension 4. Every rectangular box that you see in this picture denotes a cell in that dimension. So up here in dimension 4, for example, there's exactly one cell, and that's the sort of top dimensional cell. Now you may notice pretty quickly that there's a connection between these diagrams. They're not sort of wholly independent, and that connection is that in every picture the boxes in one diagram correspond bijectively with the lines in the next. So this little SVG file, which you can download with the Orchard source and open in a browser, this is just Google Chrome here, is going to illustrate this for us. So if I move my mouse cursor over this this box right here, you can see in the picture that it highlights the little red line that it corresponds to in the next dimension. And if I continue up here, you can see it just goes through each of the lines. By the way, I think a nice way to picture what's going on here is to think of each diagram as like a sort of stack of boxes. And the shading here gives you an indication of how I think of the stack. This one looks like it's sort of a pyramid that we're viewing from the top. So this is the lower outermost one, and you can tell because it leaves the interior blank there, and then we're sort of moving up the pyramid. So in the first diagram here, we're looking at it in a top-down view. And this here is the top dimensional, or the top cell. Whereas over here in the next picture, what we see is the lines are exactly a side view of the same picture. So that's, as I said, is on the bottom and moving up to the top. And the same analysis applies in the next dimension, but on the other hand, it's slightly more complicated. But here you can see if the outermost box corresponds to the bottom line there. And then as we move up through the tree, we pass over more and more boxes. So this outermost box has 2 boxes immediately interior to it, and those will correspond to the 2 lines over here. You can see the first one is that one on the right, and the next one is the one on the left. And as we pass through the more interior boxes, we move from the bottom to the top of the tree. So again, if you think of this whole thing right here as a stack of these boxes with these 3 here on the top, then we're sort of moving out towards the bottom and in towards the middle. And right, and again, the same analysis applies in each pair of adjacent pictures. And finally, we arrive at the top dimensional cell, where we have 2 inputs and a single output. And so the quick and easy definition of what an opetope is, it's any diagram, any sequence of pictures that you can make satisfying exactly this connection between each dimension, such that the first nested sequence of boxes is linear, and the last one is a single box. And if you work out in low dimensions the possibility, I think you'll get a sense of exactly what the opetopes are. So I'll leave it there for now, and we'll come back next time and look a little bit more closely at the structure of these diagrams.